So question number 13 is something like this. Let's try to see. A uniform magnetic field exists in a direction perpendicular to the plane of a square loop. Okay, so here I require a square loop. That's great. So to draw that square loop, something like this. Okay. And a uniform magnetic field exists perpendicular to that. So any direction I can show. So this is the magnetic field. The wire has a diameter. So this is the diameter and total length of 30 centimeter. So if the total length is 30 centimeter, if I represent that by L, L can be written as 4A, where A will be the side of the square. D is the diameter of the wire. The magnetic field changes at this particular rate. We need to calculate the induced current in the loop, and even the resistivity has been given. It's a very straightforward one. Let us break down into two components. First of all, let's see what would be the magnitude of d phi by dt. That's going to be A into dB by dt, and that itself is the EMF, right? That's how it goes. How can I calculate the area? That's of course equals to A square, where A is a known quantity, and even dV by dt is known. That's the EMF. What about the resistance? The resistance of the wire is rho, and the length, which is L or 4A, whatever you wish to write, by the cross-section area, that will be pi d square by 4. That's the total resistance of the wire. All done. EMF is here, resistance is here. Yes, a little bit of patience would be required while computing that. So the current will be the EMF divided by resistance, and you would land up with option number 2. The next one. The next one, that's from calorimetry. Now, let's see what does it say. There is a calorimeter of water equivalent 20 gram. That's great. So if the water equivalent has been given, so it means as regard to heat, either you consider the mass of calorimeter, its specific heat, or simply treat the calorimeter as 20 gram of water. So that's the water equivalent. And it contains 180 gram of water. And that initially is at the temperature 25 degrees centigrade. Now, m grams of steam at 100 degree is mixed, something like a coffee making machine, and m gram of steam has been put there, and eventually the temperature becomes 31 degrees centigrade. That's a final. The steam loses the temperature, and these guys, they gain. That's how it goes. And we need to calculate the value of m, very close. Latent heat of water, in that case, it's been given 540 calorie per gram, and the specific heat, they are almost a known value. So where is the calculation? The heat lost by steam will be gained by water plus calorimetry. So let me start with the steam. So that's, 540 m. Everything will be in this unit where mass would be in gram. So the units are not a problem. This much is the heat evolved by steam when it comes from 100 degree steam to 100 degree water. And now this steam has become water. So that will be m, specific heat is of course 1, into the temperature, that's 100 minus of 31. So the left equation talks about the journey of steam from 100 degree to water at 31. And the recipient of that heat is 180 gram of water and calorimeter of water equivalent 20 gram. Sum total, that's equivalent to 200 gram of water as regard to heat computation. You can't use water equivalent otherwise. And 200 specific heat capacity is 1, right? And how much is the change in temperature? 31, 25. So that's going to be 6. And a little bit of solving, which is almost done. The value of mass will come very close to 2 gram. So that's what the answer says. So that was about question number 14. Let's go to question number 15. Question number 15, if someone is a bit particular, then it doesn't require any calculation because the nuclear radius is in the order of 10 raised to the power 17 kg per meter cube. But if you want to solve it, the density will be, the mass of proton and neutron is given, if I represent by m, into mass number is the total mass by volume 4 by 3 pi r cube. And if you do that calculation, that will be in the order of 10 raised to the power 17 kg per meter cube.